Chat. Today we are starting on exponential functions, and as we do exponential functions, we also study logarithmic functions. The most important thing that we need to bear in mind is the definition of exponential function, which you dealt with in grade 10 and 11. And just as a reminder, a function is referred to as exponential if a function y equal to a to the power x is such that your a is greater 0 and your a can never be a 1 and your x is a member of real numbers. So I'll state an example for you of an exponential function. F of x equal to y equal to 2 to the power x is an exponential function. I can also have f of x equal to y equal to 2 to the power minus x. But because we understand exponential functions connected to exponents, we can rewrite this as y is equal to 2 to the power minus 1, or this to the power x, which then becomes 1 over 2 all this to the power x. That's still an exponential function. The other important thing that we need to know are the key features, which I am going to just enumerate. Number 1, you need to know that all exponential functions cut the y-axis at 0 and 1. Exponential functions have got a horizontal asymptote. Exponential functions have the domain as x is a member of real numbers, and the range is y is a member of real numbers, but our y is greater 0. Very, very important for us to always remember. And we all have seen that we said the exponential function is basically written as a to the power x. If our a is greater 1, a greater 1, it implies that the exponential function increases. If our a lies between 0 and 1, it means it's a proper fraction. The exponential function decreases. Very, very important for us to always remember. And last but not least, on main features, the graph is a one-to-one function. So, one-to-one function. Always, all exponential functions are one-to-one functions. So we will look at an example together. Example number 1. Now I'm moving a little bit faster. This is what we all know, and I'm reading. Solve for x if 27 multiplied by 3 to the power x plus 1 is equal to 1 over 27 to the power x. What you need to do here is to write the 27 in exponential form. It is 3 to the power 3 multiplied by 3 to the power x plus 1 is equal to 1 over, that's 3 to the power 3, or this to the power x, which means it's 3 to the power 3x. We are simply applying exponential rules. So when we multiply the same base, we add the powers. So it will be 3 to the power x plus 4 is actually equal to 3 to the power minus 3x. Very, very important for us to always remember. Now, therefore, since it is the same base and we are using equality, it means the powers are equal. Our x plus 4 is equal to minus 3x. Now, if this one comes this side, it will be 4x is equal to minus 4. So what is our x? Our x is minus 1. We have solved for x. Now we are moving on to example number 2. Example number 2 says the graph of f of x equal to 4 to the power x plus 1 is shown below. This graph here, f of x, is the one that is shown in this diagram. And the question is, find the coordinates of P, where our P is very visible, it's right here. The y-intercept of f. Yes, we want the coordinates of P, the y-intercept of f. On the y-intercept, we all know that x is always 0. Very, very important for us to remember that. So, the function is saying y is equal to 4 to the power x plus 1. That's our function. And our x is 0. So, our y will be equal to 4 to the power 0 plus 1, which means we have a 4. Therefore, the coordinates of P are 0 for the x and 4 for the y. That's very important. That's our part A. Now we are looking at part B. Part B reads, find the value of A if A8 lies on F. It is important to always remember that if a point lies on a function, then the point satisfies the function. So we are saying our y, which is 8, according to this point, is equal to 4 to the power of A. And we want to find our A. At this point, we can actually write this as 2 to the power 3, and the 4 can be written as 2 to the power 2, or this now to the power A, which means 2 to the power 3 is equal to 2 to the power 2A. Because we are talking of equality, then it means therefore 2A is actually equal to 3. So our A is actually 3 over 2. We have found our A. We are moving. In part B, I had excluded the one on the power for 4. So I'm redoing. This is out now. We are now doing y is equal to 4 to the power x plus a 1. Now we are substituting the coordinates A and 8, which means 8 is equal to 4 to the power A plus 1. We are now writing this as exponents. This is 2 to the power 3 is equal to 2 to the power 2, then in brackets A plus a 1. Some of you or some learners normally forget to use brackets here, and I'm emphasizing, please, if the power has got more than one term, use your brackets. So 2 to the power 3 is actually equal to 2 to the power 2a plus a 2. We have removed the brackets. Now equating the powers, because the power is the same, equating the powers because the base is the same, our 2a plus 2 is equal to 3. Our 2a is equal to 3 minus 2, which gives us 2a is equal to 1. So our a therefore is equal to half. That's part B. Part C is saying, write down the equation G, the reflection of F in the x-axis and the coordinates of Q. So we are required to write down the equation of G, which is the equation of this one, which is the reflection of F in the x-axis. From grade 8 and 9, we spoke about reflection, which was referred to as a transformation. Reflecting in the x negates y. So in this case, we have the equation of G being given by minus f of x. Very, very important, please. When we reflect in the x-axis, we negate our y. So this is minus, what is f of x? It's 4 to the power x plus a 1. This is our g of x. And we are also required to find the coordinates of Q. The coordinates of Q are a result of reflecting P into the x-axis. So the coordinates of P are 0 and 4. Therefore, the coordinates of Q will be 0 and minus 4. Remember, when we reflect in the x, we negate y. Our last example in this case will be example number 3. We are given a graph. Here is the graph. The graphs of F and G are shown in the figure below. We can see the two graphs. G is the reflection of F in the y-axis. F of x is equal to a to the power x, and 2, 9, and point P and 1 over 81 are points on F. Determine the values of A and P. So in this case, we are looking at finding the values of A and P. We know the point 29 satisfies the given function. So let us substitute what we have. According to that point, 9 is our y and 2 is our x. So we can write this as 3 to the power 2 is equal to a to the power 2. The powers are equal, therefore the bases are also equal. In other words, our a is actually a 3. We have found a. We still need what? The value of P. Again, this point is on F, so it satisfies the function. And our function is saying y is equal to 3 to the power x. So we substitute our two values P and 1 over 81. Y is 1 over 81, which is equal to 3 to the power P. Now, this is 1 over 3 to the power 4 is equal to 3 to the power P. Please take note of that. And this is 3 to the power minus 4 is equal to 3 to the power P. Therefore, again, bases are equal, so powers must be equal. Is equal to minus 4. We are now looking at part B. Part B says, Determine the equation of g in the form y is equal to. Now, we know our f of x is actually reflected in the y-axis, which implies that x is negated. So when we negate x, we are finding g. So our g of x is equal to 3 to the power minus x, which I explained originally to say our g of x therefore is actually 3 to the power minus 1, or this to the power x, which can then be written as g of x is equal to 1 over 3, or this to the power x. Very, very important for us to remember. Part D, which is our last part of this question. Part D says, part C, I had skipped part C. Determine the equation of H, the reflection of F in the x-axis. Now we are saying we are reflecting F in the x-axis. What happens? When we reflect in the x-axis, y is negated. So our h of x will actually be equal to minus f of x, which then gives us minus 3 to the power x. This is the function h of x. Then part D, which is the last one, is saying determine the equation of R, the reflection of F in the line y is equal to x. This we have been doing in the previous lessons. We have our y being equal to 3 to the power x. What do we do to find the inverse? We reflect in the line y is equal to x. We swap x and y, then what do we have? X is equal to 3 to the power y. Now, whenever we have this, we can straight away write down the inverse as y is equal to log. What is the base? Is 3, and we have our x, which I think you saw in the test that we wrote yesterday. Thank you very much. Exercise classwork will be exercise 1, and we are doing numbers 1, 1, 1, 3, 2, 1, and 2, 3. And then your homework will be exercise 1, numbers. We are doing 1, 2, 1, 4, and 2, 2. That's the end.